Welcome to the University of Kentucky's Backyard Streams program. During this webinar, we'll explore the topic of karst. We will ask ourselves, what is karst? How does it form? Where is it found? We will also discuss groundwater quality and how its protection is especially important in karst landscapes. The term karst refers to land underlain with rock that is dissolvable by surface or groundwaters. In Kentucky, that rock is limestone. Karst formation is a product of climate and geology. As rain falls from the sky, a small amount of carbon dioxide or CO2 gas is dissolved into the raindrops. More CO2 is dissolved as water percolates through the soil. The CO2 reacts with water to form a weak acid known as carbonic acid or H2CO3. When carbonic acid encounters limestone, the rock becomes weathered and slowly dissolves, creating voids or openings. Karst landscapes are characterized by surface features such as springs, sinkholes, shallow depressions, and rolling hills. Karst regions are also known for their subsurface or below-ground features such as conduits and caves. In streams, karst features can result in losing reaches or gaining ones. Swallows transport water from the surface to the subsurface, while boils do the opposite by bringing groundwater to the surface. Karst can occur anywhere in the world that has the correct geology, meaning ready dissolvable rocks, and sufficiently high rates of weathering. Weathering rates depend on the amount of rainfall, past and present, and the amount of biological activity in the soil. In the U.S., most karst regions are found east of the Rocky Mountains. Florida, Iowa, Kentucky, Missouri, and Tennessee have high amounts of karst. In Kentucky, over 55% of the state is underlain by karst-prone rocks. Karst is mainly found in the center and western regions. Because of the difficulty in mapping karst, areas are designated as having the potential for karst, meaning that karst may or may not be present. What makes a karst region unique is how runoff drains from the land. In karst regions, some of the runoff flows into surface features such as sinkholes, where it then travels underground. Some of this infiltrated water reemerges at springs and the like, while some continues moving underground. Water that continues to move underground flows to the aquifer. An aquifer is a body of water-bearing rock located underground. Two important features of aquifers are how water is stored in the rock and how water moves through the rock. Rocks and sediment contain empty spaces known as pore space, which can be filled with water. Different types of rock and soil hold different amounts of water due to the sizes and amounts of pore space present. Limestone rock, for instance, has smaller pore spaces that are not interconnected, meaning the voids hold little water. Instead, karst aquifers store water mainly in the fractures in the rocks. Because the pore spaces are not well connected, water flow in karst aquifers occurs via fractures and conduits or large underground flow paths. Groundwater is an important water source for activities such as drinking, bathing, cooking, and irrigation. While many residents and communities in Kentucky obtain drinking water from rivers such as the Kentucky River and the Ohio River, surface water is not the only source. Groundwater obtained from springs and wells is also used. Keeping our groundwater resources clean is becoming more challenging with an ever-growing population. In watersheds underlain by karst, groundwater is more susceptible to contamination because surface waters are directly connected to groundwaters. Such direct paths into the groundwater mean that pollutants reach the aquifer more quickly with little to no filtration. While water from springs and wells may look clean, it may actually contain unsafe levels of pollutants such as bacteria and nitrogen. Pollution is classified as either point source or non-point source. Point source or PS pollution is pollution that originates from a specific location such as a pipe. Non-point source pollution, or NPS, is pollution generated from many diffuse or widespread sources. Examples of NPS include sediment from agriculture, construction, or timber harvesting operations, oil and grease from urban areas, and pathogens from livestock, human, and pet waste. Protecting groundwater quality is something we all can do. At home, be sure to properly dispose of all household waste. Trash and other debris should not be placed in sinkholes. If you have a septic system, inspect it regularly to ensure it's working properly. Be sure to pick up after your pet. Vegetated buffers, which are areas of thick vegetation such as grasses, shrubs, or trees, can be established around streams and karst features such as sinkholes. These buffers help filter sediments, pathogens, nutrients, and other pollutants from runoff before entering the karst features. In rural areas, protect karst features such as sinkholes from runoff from livestock or crop operations. Fence off these features so livestock cannot enter. Doing so will not only protect groundwater, but it will also protect livestock from injury. Thank you for completing this webinar on karst. To learn more about karst as it relates to backyard streams, check out the publications sections for additional information. Also visit our Backyard Streams website at www.uky.edu/BAE/backyard streams.